Our first talk, and you need to hear from them, not me. Our first talk, titled Why Research Matters, will be presented by Dr. Steve Dewhurst. Dr. Steve Dewhurst is the Vice President of Research at the University of Rochester and our Vice Dean of Education at the School of Medicine and Dentistry. A virologist by training, his research focuses on pathogenetic human viruses, including HIV, influenza, and SARS-CoV-2. I know him as one of my favorite collaborators, and I don't even understand all of that. Over the course of his career, Dewhurst has earned national recognition for both his scientific work and his commitment to mentoring. As a leader in academic research administration, he has advanced institutional initiatives to support research, growth, interdisciplinary collaboration, and innovation. It is my great honor to introduce Dr. Steve Dewhurst.
Thanks, Sarah. So I wanted to talk a little bit about why research matters as a very broad theme. I think many of us feel that at the moment, the value of expertise and experts is being challenged in ways that are detrimental. And that part of the reason that's happening is that we've not done a good enough job at communicating why research matters, why what we do matters, why the academic medical center is such an important thing for our country. So I want to spend a minute to frame that, and then Ruth and Ryan will provide a little more color in terms of specificity around the kinds of things that happen at a special place like this. So just as a reminder then, research is essential for discovery, informed inquiry, and evidence-based solutions. It helps society address complex problems in ways that are practical and effective, makes people's lives better. And that's a theme that we really need to get out there more effectively than we have. And it drives economic growth. And you sort of hear that a little bit in some of what Jill had to say in the sense of, where does our lead in biotech come from? It comes from federal investment in fundamental research. And I'll really go through that theme. So this is a book that came out a couple of years ago. It may be familiar to many of you in the audience. These are two MIT professors, one of economics, one of entrepreneurship. They were looking at the innovation economy in this country. One of the things they concluded is Rochester is at the top of the list for places in which the innovation economy has the ability to grow. That reflects the long history of entrepreneurship and patenting in this community. They also pointed out that in the years following World War II, we led the world in innovation, and we created through that fields like jet aircraft, microelectronics, satellites, digital computers. And one thing I want to say about that, right, that is a direct outcome of President Kennedy saying in 1961, we're going to put a man on the moon and return him safely to Earth. That's one thing. The ancillary benefit you get out of that is all of those things: satellites, microelectronics, digital computers. That benefits everybody's lives in America, worldwide, economically for our country. That productivity, according to these two professors, slowed. And one of the major reasons it slowed after World War II was a retrenchment of investment in US R&D. So we used to invest 2% of our GDP, gross domestic product, in research. That's now 0.7%. So that's an important thing to frame, that when our economy was growing at its fastest rate, post-World War II was the time we invested the most in fundamental science. They also point out that really it's the synergy of private enterprise with fundamental research funded by the federal government that's the most successful model. And so I'm just bold-facing, again, a quote from the book, but spillovers from discovery are incredibly important because they create not only fundamental knowledge, but also the basis for the applied ideas that grow the economy. And that leads to new gene therapies, it leads to new treatments that better the lives of individual human beings. This is a slightly complicated slide. I don't want to go through all the details, but it's a paper that came out earlier this year in one of the JAMA family journals. And it looks at what is the history behind new drugs that are approved by the FDA in this country. So it's summarizing NMEs are novel molecular entities, so drugs. You'll see that over that 10-year period, the US FDA approved 365 new drugs. So that's about 30 to 35 a year, and I'll come back to that in a sec. The important thing I wanted to sort of frame is actually down the bottom. So NIH funding is incredibly important to defining the targets on which these drugs act. So you can't have a drug if you don't know what molecular target you want to direct it to with the anticipation of therapeutic benefit. That's really where most of NIH's support goes, and that's essential to pharma's ability to develop a drug subsequent to that. So NIH does invest in some work that relates to the drug search, but mostly it's the fundamental knowledge. You see it in the publication numbers, in the funding, and in the way that NIH directs its funding portfolio historically. You see the same thing in this slide. It may look a slightly complicated slide, it's really not. So here's the year of drug approval. So one thing that you get immediately is it's a 20-year history to get the drug approved. NIH is who funded that in these previous years. So the funding goes up, it reaches an apogee, and that's roughly when the handoff starts to a commercial sector to industry, right? And so then NIH's investment can decline because there's a handoff to where the drug is now being developed. And again, we'll hear some of how does that play out for patients in what Ryan and Ruth have to say. So to go back to the role of the university and framing why what we do is so important, it sounds a little grandiose, but it's true. We seek truth, objective truth. We ask hard questions and we have real world impact. We turn ideas into action, regardless of politics. It's also true that as an institution, we've not had a marketing function. That'll sound, again, funny for some of you perhaps, but it's actually really important. Marketing is about communicating what we do and why it matters. So we recently hired somebody who has that function for us centrally. And these phrases down the bottom actually come from some work that they did with our research community to put in words what it is that we do. And, you know, we're not all the most eloquent. And so this rigorous wonder, I really like that phrase a lot. I'll come back to that. So the wonder is the curiosity. That's why we do what we do. But the rigor, we're scientists. We're not just studying it because gee whiz isn't that interesting. We're studying it for a reason, purposefully, with rigor. And then the humanistic innovation, I think that's so important for this institution too, right? You look at the biopsychosocial model. That is the core of our medical education. It is the core of our identity as an institution. What we do benefits individual people and societies and populations. So that's the kind of framing that really does, I think, help us communicate what we do. I want to give you just one or two examples. This is an example of the phrase purpose and intention. This is one subunit within our Department of Neurology, Center for Health and Technology. They do large multi-center trials in the neurologic space, principally in Huntington's disease and Parkinson's disease. Those trials are responsible for 10 FDA approvals. And remember, I said there's only about 30 to 35 a year. So they have had an outsized impact on the health and well-being of people living with Parkinson's disease and Huntington's disease. And that's a measure of the impact of this institution and researchers particularly in this instance, in neurology. Wanted to take a moment to talk about rigorous wonder just to give you an example. This is a collaboration between our River campus, the Department of Biology, and the medical center, and I'll come back to clarify that. But this is Vera Gorbanova's work. This figure looks at the relationship between lifespan and body mass. And if you take a moment to think, right, very small animals like a mouse, they live a couple of years, right, 3 years. And then you think about us, we live a much longer time period. And broadly speaking, that relationship is essentially, it's a linear relationship, log linear. But there are some animals that are really interesting that don't fall on that curve. So one you'll see is human beings. We live longer than we should. Well, why is that? That's because we've gone out there, public health, clean water, vaccine. That's why we live longer. If you look at these, though, there's something else intrinsic to the biology of the naked mole rat that many of you may have heard of. That's an organism that Vera studies. It lives 10 times longer than it kind of should. So why? Super interesting question. The other animal that she's been very interested in recently is the bowhead whale. That's the longest lived animal on the planet, lives north of 200 years. So she's working with native populations in Alaska to sort of study, well, what's special about the bowhead whale? One of the things that has come out of that work, both in Vera's lab and in many others, is this relates to this phrase, the dark genome. So it's one of those sort of evocative phrases that, again, works well in a communication. So 2% of our genome is what's called the exome, so the expressed genome, makes protein. The other 98%, kind of mysterious. Most of that mysterious dark genome turns out to be retrotransposons. So that is, these are relics of RNA viruses integrated into our chromosomes. Some of them do stuff, some of them we don't quite know what they do. So that's, parenthetically, that's an interesting thing about viruses, right? They are amazing parasites of every animal out there. This becomes very relevant to aging, though, because these are derived from viruses, they mimic viruses. And one of the things viruses do is they activate the immune system, and they'll lead to an immune response, including an interferon response. That's perfectly good in the context of an acute infection. It's not so great in the context of chronic ongoing inflammation. That's not a good thing. And so that activation of a retroviral element in the dark genome leads to things like transcriptional noise, inflammation, cell death, DNA damage, mutation. All of that in aggregate adds up to aging. One of the interesting things that Vera, she has a pending proposal that relates to this theme. This is a theme where we're looking at a variety of molecular clocks. These are different people's idea of what a molecular clock for aging should look like. And green is basically, this is a series of interventions. Green means that the aging process has been slowed. Down the bottom would be the opposite, aging has been accelerated. I'm not going to go through the details of the slide, but just two things that I've highlighted. Kidney dialysis, if any of you are familiar with that, it's a horrible thing to have to live with. And so that accelerates aging. That is sort of intuitive validation of this representation of data here. The one at the top is the surprise. That's antiretroviral therapy. So antiretroviral therapy has life-extending qualities independent of what it does to HIV. Why is that? And the reason is that it shuts down these retro elements, right? Retroviruses, HIV is a retrovirus. So the drugs that target HIV, some of them cross over to these endogenous retroviruses. And there's reason then to think that a therapeutic intervention there would have a positive effect on aging. That's also then becomes a question if you start to think about neurodegenerative diseases that are also associated with aging. The greatest risk factor for Alzheimer's is age. So why is that? So this goes to the collaboration, Kerry O'Banion and Vera Gorbanova, Med Center River Campus. It's the kind of thing that we do very, very well here. Many of our peers struggle to do this kind of collaboration. In summarizing, one of the things, again, I started by framing that my intent here is to try to have us all do a better job of communicating the value of science. This is a Pew Research Center survey of what the public think of scientists. You know, they think we're smart, that's good. But they don't think we're very good communicators. And unfortunately, that's true too. So what are we doing about that as an institution? One of the things is to try and humanize our researchers. So this is from our Del Monte Institute of Neuroscience, that John works closely with an artist in residence, Charmaine Wheatley. This is a watercolor drawing of Kerry O'Banion that you just saw in the previous slide. And it sort of, talks about Kerry saying he looks like his dad. Charmaine represents pieces of conversation as she creates these portraits. But it's also a jumping off point to talk about Kerry's research and his collaboration with Vera. And so the boldface piece tells you why is Kerry a neuroscientist working with Vera, an aging scientist? That's why. So it gives us a way of really opening a conversation. The same way our marketing and communications people are engaging with people who've been involved with clinical trials. And so these are people speaking in their own authentic voice about their experience. So it's a very generous thing of Hannah to do in this instance, right? She's sharing something extremely personal. So it's 27-year-old. Imagine, one of your own kids, right? Your daughter, 27 years old, has stage 4 cancer. So she had stage 4 cancer. She was enrolled in a clinical trial at Wilmot with Jonathan Friedberg, actually, as her physician. And she received a cutting-edge immunotherapy that changed her life, and didn't just change it, it saved her life. Not every clinical trial participant will have that outcome, but people participate in trials because they want to make the world better and they want to improve opportunities for other people. I'm a chronic trial participant myself. I've been in a bunch of trials here. And anyway, so I'm a strong believer in that. Also important to emphasize our economic impact. Our government relations people are actually working on a new economic report, but last year we received $188 million from the NIH, fiscal 24. That's roughly 2,000 jobs here. It's roughly 420 million in economic activity. There's a multiplier effect. If you want to, have just one talking point, the HPV vaccine, we often refer to that then as the world's first ever vaccine for cancer. That saves hundreds of thousands of lives annually. That came out largely from our Division of Infectious Diseases in Ruth's department. So finally, just to circle back to where I started, this was a report that was provided to President Truman at the end of World War II by Vannevar Bush. It's a very famous report. It led to the founding of the National Science Foundation, among other things. But what Bush had to say is true then, is true now, is true of NSF, is true of NIH. Basic research drives technological progress. Goes on to say that the most important ways the government can promote industrial research is by funding basic research, by funding discovery research, and by developing scientific talent. And if you think about what distinguishes the academic health center from a regional hospital, it's those two things. We do research and we train the next generation of clinicians, scientists, nurses, you name it, that's what we train. Finally, the last thing that I personally am very fond of is he was a big fan of curiosity-driven science. Let people study what interests them, because that's what drives us, right? We all have our own reasons for what we do with our time, what we do with our lives. And leveraging that, it gives tremendous societal benefit. So with that, I'm going to stop there, pause and see if there are any questions or anything anyone wants to share.
My name is Dan Levy. I'm a pediatrician. I've had all kinds of positions of leadership. And we're at a time when the message that's coming from the federal government is be afraid of what you don't understand. You know why I'm saying this. I also can say that as a pediatrician, my particular chosen profession has been impugned by certain people in the government. So I'm saying, I don't have a question so much as a comment to say thank you, both because I'm so proud to be a U of R graduate 50 years ago, but also because there's so much for us to communicate to the public about what you do that's not being done. And particularly by my organization, the American Academy of Pediatrics, I think that people are increasingly valuing what we say, but we're getting so much noise from the other side. So thank you so much for your comments. It really meant a lot.
Thank you. And we're going to progress on. And, Dan, I would also say, I think all of our physicians and providers have the same commitment you do to their patients and to ensuring the well-being of the people they serve. And that's not going to change regardless of anything else. And you'll hear that both from Ruth and Brian, who are practicing.
Thank you, Dr. Dewhurst. What a great way to start.